In this tutorial, I'll show you how to design the reference shape of your shape model. We'll go from this noisy segmented mesh to a clean and smooth mesh, which will dramatically improve the usefulness of your shape model. Hi, and welcome to Coding with Dennis. My name is Dennis. This here is the third tutorial in the series on how to create statistical shape models. Choosing a good reference mesh is a very important step, but unfortunately also often overlooked. By mastering this step, you'll be able to create statistical shape models that generalize better and can be magnitudes faster and easier to use. It is very important to keep the final application of the shape model in mind when choosing a good reference shape. A model used for animation, in contrast to a model used for segmentation or for feature point extraction, have very different requirements. So let's go over the most common strategies. First off, the most common strategy is to choose a random shape from the shape dataset. The benefit of this is the process being fast, but this comes at the price of potentially bad generalization or inheriting biases in the chosen sample to your dataset. If we look at our extracted vertebra meshes, we also see that they are rather noisy. This noise might stay within the model if not explicitly removed. Another common method is to design the reference fully manually. The benefit of this is 100% control of what the reference contains. This is popular if none of the data items in the dataset is complete, or they might all contain a certain level of bias. The Basel face model shown in the demo video is, for instance, designed by an artist where they have increased the triangulation in areas of high detail, such as the eyes, ears, mouth and nose, whereas large surface areas are with more sparse triangulation. The negative side of this is the time needed to create such a reference, as well as the expertise that is required to use a 3D modeling software. In my opinion, the best initial option is instead to correct a random shape from the dataset manually. This will be both relatively fast and we'll be able to generalize well if we manage to remove the patient-specific biases. For this, we'll shortly go over an example. The fourth choice is in addition to the first three steps. The strategy here is to bring all the meshes in point correspondence with the chosen template and then compute the mean shape, which is what we'll use as the new reference mesh. This step can then be iterated until the mean and the reference mesh converges to the same shape, which usually happens already after one or two iterations. Now for the semi-manual reference creation, I'll use two different programs. These are MeshLab and MeshMixer. MeshLab will be used to align the mesh and apply different simple filters to the mesh, such as smoothing, sharpening, triangulation, decimation, and so on. Whereas MeshMixer will be used for manual correction of the mesh. Oftentimes I even go back and forth between these two programs a few times. Of course, many more options exist out there, such as Blender, Unity, Maya, and many more. If you already know some of these softwares, definitely go ahead and use those. So let's get started and create a reference mesh. For this, I'll choose a random mesh from the vertebra dataset, as mentioned in the introduction tutorial of this series. The very first thing I normally do is to align the mesh to the origin and rotate it in the direction you're interested in. This can be either done with Scalismo, as shown in the previous tutorial, or we can do it semi-manually, for instance in MeshLab. I typically try out an automatic alignment first. In MeshLab, this is found under filters, normal curvatures and orientation, and then align to principal axis. This will align the principal axis of the mesh to the X, Y, and Z axis. Alternatively, the center of the mesh can be manually set with the translate filter. Likewise, if the rotation of the mesh is not as you want, each individual axis rotation can be specified with the rotation transform. Of course, aligning the reference is not strictly necessary, but it'll make it much easier to, for instance, specify region-specific kernels, which we'll see in one of the following tutorials. Next up, we'll save the mesh and open it in MeshMixer. Now it's all a matter of using the different sculpt tools to clean up our mesh, or using the select tool to select items that we do not want in the reference. If the triangulation is very coarse, I usually start out applying the refinement method to the mesh and thereafter either draw, flatten, drag, move, or use one of the smoothing tools to clean up the mesh. Again, the goal here is to remove noise as well as all possible biases that the mesh might have. We can also manually increase the triangulation in some areas of the mesh and decrease it in others, again depending on the use case of the model. The last step I do is to decimate the mesh. You might want to avoid the step if you already manually define the coarseness of the mesh everywhere you want. Let's try out different decimation levels and see what it looks like. I prefer the mesh output from the quadratic edge estimation algorithm. Again, the amount of the decimation completely depends on your usage of the model. The more the mesh is decimated, the fewer points it will have, thereby it will be faster to compute and take up less space. But it will also not look as good when rendering it. The same decimation algorithm is also available directly in Scalismo. To use it there, you simply load in the mesh, perform the decimation operation and save the mesh again. Like this, you can even have different coarseness level of your reference mesh available. And that's all there is to it. Some simple steps that will save you hours, if not days of work, down the line. In the next tutorial, I'll show you how to design kernels to deform this chosen reference mesh in order to use it for non-rigid registration. And that was all for this video. Remember to give the video a like, comment below with your own shape model project, and of course subscribe to the channel for more content like this. See you in the next video.